All right, imagine this. It's 2012 and you've just had a brilliant idea. You want to start a company with a simple mission. Enable every merchant to deliver. That's your goal. And you want to know how you can make that happen from a technical perspective. Now, I'm not going to give you the answer that you should necessarily give in a design interview if you're trying to get your first job, okay? But what I am going to do is try and give like a realistic, practical guide for how I think that this type of project should unfold. All right, so for the purposes of our exercise, let's be a little bit explicit about what it means to build DoorDash, okay? Here are the use cases that we're going to consider our MVP, and this is generally how I would break it down if I were actually trying to build this tomorrow, okay? First, stores need to be able to sign up to be able to take orders through DoorDash, obviously. Drivers need to be able to sign up to perform deliveries for DoorDash, obviously. And customers need to be able to sign up to order food through DoorDash, obviously. We have these three types of users and they can overlap, right? You could drive for DoorDash and order for DoorDash, but these are three separate users, three separate types of people that are using the service. When an order is placed, it's sent to the restaurant, duh. And of course, finally, when an order is placed, a driver is given the restaurant and the customer address. That's kind of all you need for like a basic MVP. Obviously, when you're looking at the perspective of how DoorDash exists today, there's more than this. You get fancy maps, you get like order tracking and like, oh, what stage of the process is it in a little bit, but whatever. We're ignoring all of that. These are our very basic versions of how we should build this out. We need to get these very core flows done first. All right, now I feel like the very next question that a bunch of people ask is what tech stack would I use, right? What is the fundamental technologies that we need to use to build something like DoorDash, okay? It doesn't matter. As long as you are asking yourself questions around which technology is better. Oh, should I be using Svelte 3 so that I get faster compile times and that the website loads faster? The longer that you spend thinking about these really arbitrary things, oh, is SQL better than no SQL? These are times that you could be getting customer feedback, okay? You could be getting user feedback. You could be understanding more about what your users need. You do not need to care at a very basic MVP level for any of your projects ever what the tech stack is. If you're trying to get hired and so you want to like check boxes on whatever tech stack the company that you love is going to use, great, fine. But some of the biggest websites that you know of today were built on the back of just whatever was the most popular at the time, right? Facebook and PHP. It's still basically written in PHP, and PHP is not like an elegant language. It's not something that people love to work in, but it was incredibly popular at the time, and it was really easy to get fast going, okay? If it were me today, my version of this, because of my personal experience, is I would probably pick like Python as a backend, and I would pick like Angular as a front end, or I would pick React as a front end. It doesn't matter, okay? You don't have to do either of those. If you're more comfortable doing server-side rendering, maybe you like HTMX, it doesn't matter. Your tech stack is not something that you should spend more than like 10 minutes thinking about. All right, so along those same veins, we're going to look at our very first architecture diagram. Boom, here it is. We're going to have a client. That's probably just going to be a website because it's easiest. We're going to have a server. Maybe that's Python. And then we're probably going to just send JSON back between them, okay? It doesn't really matter. Oh, but GraphQL is really hot. Should I be using GraphQL? Probably not, okay? It's probably going to slow you down. Whatever the thing is that you're fastest at, that's what you're going to start with because your idea might be bad, okay? DoorDash's idea, we have the idea already. But in 2012, DoorDash could have been bad. It could have not worked out. And so the best thing that they can do is talk to customers after building a version that they can actually use. Okay, we want to get real feedback from real users. So because of that, we should start incredibly simple. Okay, server, client, boom. And sure, over time, the server is going to become bigger and bigger and bigger and bigger and bigger, and we're going to run into problems. And we're going to talk about that. But you shouldn't worry about this on day one. You shouldn't worry about having this problem. You shouldn't ask yourself, what am I going to do when I have 1 million users if you don't have one? What's going on in this server? Okay. We've talked about this idea that we're going to have this one monolith at first, okay, that we're eventually going to carve out, but how are we actually going to structure things? So from our use cases, we know that we have 3 types of accounts, okay? And so now is where we got to start thinking back to, I'm sure all of you took some type of object-oriented programming class or program design class or something along these lines. So if it's me, I'm going to start by making an account, okay? An account is just gonna have your core concepts of login and things like this. You're gonna have like username, password, probably some contact information, things like that. And then when we need to start differentiating between these accounts, we're gonna have this concept of a business, a driver, and a customer. Those were our 3 types of users that we identified. And I'm just gonna have these have an account, okay? I'm probably not gonna do subclassing am not going to do like a strict inheritance type structure because I kind of don't like those things. I think it's a little bit less flexible. I think that later on down the line, it's harder to disentangle these things because you start throwing too much logic on there, and I don't really like it. Okay. I'm more of a composition over inheritance type guy. All right. You don't have to do that, but it's my video. All right, so which use cases are we going to build for these different account types, right? So we've already talked about the fact that businesses need to be able to accept orders. Okay, so what does that mean? We need to be able to upload a menu. We need to be able to set hours. We need to be able to override those hours in case for an emergency we need to close. And then we need to be able to receive payment for the fact that we've just had people order food. Okay, that's pretty much the gist as like a total MVP. Oh, and obviously we need to be able to actually like receive those orders. From a driver perspective, all we really need to be able to do is enable/disable the fact that we're available for deliveries. We're going to say that DoorDash gets to tell you whether or not something's in range, and you get to accept or decline the order. All right. And then we need to be able to receive payment. That's kind of it. Oh, and obviously we need to send you orders to pick up. And now finally, as a customer, we've got to be able to see nearby restaurants, view their items, check out, make payment. That's kind of it. That's kind of the shtick. Now, from a core methodology perspective, I'm probably going to build in almost exactly this order. Okay, because I feel like it's very important to get the general flow for a business out of the way, then the general flow for a driver out of the way, then the general flow for a customer out of the way. This is how I would do it, because unless businesses want to be able to use your service, then you don't have a clientele. So I'm going to prioritize first and foremost getting something that's smooth for a business to onboard onto and make it easy for them. Okay, then same idea. You need drivers. Drivers are going to be like your bread and butter of whether or not there's a good delivery service here. Okay. If you don't have enough drivers, it's going to take too long. No one's going to want to use your thing. And so businesses aren't going to be willing to give you a pay cut. So because of that, we've got to make sure that it's also easy for drivers and that in general, it makes sense to them and there's not a lot of like lift. Then customers are pretty much going to use your service if the businesses that they want are on it and the drivers are actually, available for deliveries. So I'm actually probably prioritizing the customers the least out of all of this, what their experience is like. To me, these are kind of your real reach critical mass points, is make sure that this is smooth, and then we'll worry about this later on. All right, so what's this first use case going to look like for a business? Okay, updating their menu. All it's going to be is we're going to send over like sections of a menu, and each section is going to have a name for it, and then it's going to have items inside of it. Those items are going to have a name, a description, and a price. And that's it. That's our MVP. Okay, we just have menu, update. This is one of our APIs. Boom, banged out. Now would be a good time for me to probably separate out that this is not a video where I'm going to teach you about what it means to build an API. Okay, I'm kind of assuming that you've like built something on the internet before, whether or not it's simple. So I'm not going to go over like what it means to have an API and why you need to break these things up this way. Okay, unfortunately, you're not ready to build DoorDash if you don't have like a basic grasp on client server communications. All right, your hours for the day, right? Super easy. We're just going to have an array of days, 0 through 6. All right, 7 entries, pretty straightforward. I think you can guess what corresponds to what. And then we're gonna have an open timestamp and a closed timestamp. This is gonna tell people when they can and can't place orders. All right, we're moving right along. We're banging these out. Schedule/override. Okay, this is to be able to override our hours like we said businesses need to be able to do. We're gonna have a state, whether or not you're open or closed. When that time starts, maybe you need to like schedule this as in like 20 minutes, we're gonna close. And we're gonna have until. And then as soon as the until hits, we're just gonna clear this status. And then that's it. We're going to go back to our normal scheduled hours. Okay. Super simple. We can build stuff on top of this later if we really need to. There's going to be complexity in how you implement these things on the back end, but these are the APIs. All right. Now it's time for a restaurant to receive orders. If you don't know what a socket is, it's basically a way for a server to push information down to a client. That way you don't need to like poll and keep it saying like, get me all my orders, get me all my orders. I'm not going to go into the nitty gritty of like why that's worse, but it's worse. Okay. You want to have like a more real-time setup going on here. The server should be able to push information down to the client that's going to be running in the business and say, hey, here are the items that someone ordered. And here's the customer name that it corresponds to, so that when a driver shows up and says, hey, I need an order for Joe Schmo, you know who that order goes to. Okay. It's very simple. Look it up if you don't know what sockets are like. They're very useful. You should do a little project with them before you're trying to build DoorDash. Okay, so we've taken care of everything for a business except for receiving payment. I'm going to be real with you. I'm not dealing with that. I'm going to let Stripe deal with that. I'm just going to integrate with Stripe. If you don't know what Stripe is, they're basically a payment processor. That is what I would use. Okay, I would let them handle all that payout stuff. I don't know exactly what that integration would look like, but I would go through their docs. I'm sure that it's pretty reasonable. We're not going to spend a lot of time thinking about that right now because they're kind of just like a third-party API that you would have to integrate with for all of this payment stuff. So I'm going to be really hand-wavy about the payment and say that we're going to integrate with Stripe. All right, for a driver, they want to be able to say whether or not they can receive orders right now. We're going to give them a start date time. Why? In the future, maybe it's useful for them to be able to schedule this so they don't just have to say like literally right now. Okay. I think that this is useful to build into the API design because that way we don't really have to make client changes later on down the line if we want to allow people to do like weird scheduling type things of every Thursday I'm available at these hours, right? Like we're not going to necessarily worry about that on day one, but just by throwing a timestamp in there, we give ourselves more flexibility. Now, status makes perfect sense whether or not you're available or unavailable. If you're set to available, we're going to start giving you orders after that timestamp. If you're unavailable, we're going to stop giving you orders after that timestamp. Okay, here's our most complicated API to date. So we've already talked about sockets. We're sending information from the server to the client. This is what we want to do here because when you get a new order, we want to push that to you. Okay, something that a driver is going to pick up. Now, we're going to give an order UUID, and we're going to explain why that is later. And we're going to give the business's name, an approximate location, like, oh, it's 3.5 miles away from you, and the address of the business. Okay, this is to help someone decide whether or not they actually want to do this. Maybe they're like, I don't feel like driving 3.5 miles away right now. And the address is like, maybe it's a bad part of town. They don't like it, whatever. We're going to show that to them. Now, the customer, this is like the first piece of potential insight that I have here. The customer, we're not going to want to give them the address up front. Okay, we want to give them an approximate location. Like, okay, we're going to drive 3.5 miles to the restaurant. And then from the restaurant, we're going to drive 2 miles. But we don't really want to be like giving out the customer's address willy-nilly. Okay, until we're like at a point where we know that you're going to service this customer, we don't want to give them the address just for privacy reasons. Okay, it's nice to be able to keep that as private as humanly possible. The big important thing here is we need to be able to accept or deny this order. And you need to have like a time window. There's a possibility that a driver says that they're available and they walk away, and it's a really bad experience for a customer to just be waiting and waiting and waiting on a driver to acknowledge this, right? So it's important that we have the driver acknowledge. It's important that the driver has a specific time window that they can acknowledge within, and otherwise we will find a new driver. So unless we get this back for the corresponding order ID with a status of accept, we will, within, let's say, a minute, 2 minutes, who knows, try to find a new driver, right? And then we'll remove it from the queue for this person. And then if after the fact, they're like, hey, oh, I wanted to accept that. We're like, oh, sorry, too late. Someone else got the order. Okay, that's it. This is our basic API breakdown. It's the most complicated one that we have so far because we need some like acknowledgement back and forth, but still pretty straightforward. Okay, so like we said before, we're going to be hand wavy on payment. So driver, we're going to consider to be done. Receiving payment is going to be Stripe's problem. All right, moving right along. We're a customer. We want to see the restaurants that are nearby. We're going to send a request giving our general location, right? And generally, I'm pretty sure that online we use latitude and longitude to represent geographic locations. I'm pretty confident that that's correct. So we're going to say that we're going to send over a latitude and longitude, and then we're going to send back within some fixed radius a bunch of restaurants, okay? I'm sure eventually it's probably worthwhile to let people look at a larger radius, and so you would maybe include in this some type of like, oh, I want to search within a 10-mile radius. But for right now, we're going to say that DoorDash is making the decisions of what is available for delivery near you, what is a like too far, too close, etc. Now, all the server is going to give us back is just the name of a restaurant and its approximate location to you. We're building really light, okay? In general, you're probably going to send back like image URLs that are going to be like the stock photos that a restaurant wants you to see of their food. Okay, but we're building really light at first. Okay, super light. We're just really prioritizing getting some feedback first. Oh, and I forgot to draw this in at first. We need an ID for the restaurant because that's how we're going to fetch the menu in a second. Okay, so now it's time for us to actually get the menu, and we're going to send the same exact JSON stuff over that we used when we were saying that the restaurant is going to set the menu. There's no reason to overcomplicate things. This can literally just be the exact same structure. We have sections to the menu. We're going to have items. Those items are going to have prices. One quick thing I should note is that when we send the items over to an actual like customer, we're also going to have an ID associated with that item. We're not just going to make you look it up by name. So this way, when we get to the next section, we're going to use these IDs for when we're placing an order. All right, when we're placing an order, we're just going to send over an array with IDs that correspond to the item IDs for that restaurant. And then we're going to do all of the calculation on the server side so that people can't lie and be like, oh, this item is actually worth $3, right? You want to be able to just look up and see what the prices are on the server side. You shouldn't trust that information from the client. So we're going to send over just the IDs. Why is this an object? Because eventually I'm sure we're going to want to build things like special requests and modifications and blah, and all of that's going to go on the item ID. So we might as well build into the initial version of the API the fact that we're going to take back an object as opposed to just a list of strings that are the IDs. Okay, this is pretty much all we should need here. Now, again, we said that we were going to be hand wavy on payment. So we're done with these basic sets of things that we need to build from an API design perspective. So now we're going to have one large server that's going to have all of these things built into it. Okay. And ideally, these things are going to be built in such a way that only like business accounts are sending over requests to the business APIs. Driver accounts are sending over requests to the driver APIs. Customer accounts are sending over requests to the customer APIs. Okay. So how are we going to do that? All right. So if you've never built any type of auth system before, basically we're going to have request headers. That request header is going to have an auth token. We're going to look up that auth token in our database, and we're going to say, hey, is this like a valid auth token? And then we're going to get back information about whether or not it's a valid auth token and, things about the account. We're going to look up the account. And as part of that, we're going to understand whether or not it's a business account, a driver account, a customer account. And then the server can make the decision of, oh, you're actually a driver, but you're trying to order food. That doesn't make sense. Or you're trying to set the menu for a restaurant. That doesn't make sense. We're going to give you back this 403 forbidden. Say, hey, you're not allowed to do that. Okay. Similarly, if like you're trying to update the menu of a restaurant that like is not your own menu, that we're not going to let you do that. Okay. So all of this is like, we're going to use auth tokens. They're going in the request headers. I'm not going to get super into the security aspects of these things, but we're going to have a system where we're sending over an auth token. We're looking it up in the database, and then we're going to have the server decide on these APIs whether or not these actions are allowed based on the auth token. Okay. So now we've got our MVP. All right. And we've got this huge server. It does a lot of stuff. Okay. It's got tons and tons of stuff. And let's say that now we're kind of blowing up. All right. We're getting successful and things are starting to slow down. So what are we going to do? Okay. First, the very first thing we're going to do is we're going to try and just copy these servers. We're going to run multiple of them. Okay. And it doesn't matter where you go to at all. We're just going to run multiple of them. All right. And all of these servers are going to talk to one database, one big boy database. Okay. And this is where we're going to start running into problems first, almost certainly. But we're going to have a database, and we're just going to keep scaling up the database, making the database bigger and bigger and bigger for the first little while. Okay, this is going to do well for you. This is going to get you to a large point. Okay, we're going to have a bunch of replicas of the server that can do everything, and we're going to have one huge database. All right, and this is already like we've given ourselves a lot of scalability. Okay. Now let's say that our database is throttling us, because that's probably what's going to happen first. You're going to start hitting the point where you have too much data and all of these things talking to the database, one single point of failure. It's not good. It's not good. Okay. So now our first problem that we're going to probably run into is how do we split up our data? Because we can just keep making replicas of this server, and this is probably going to work for a long time. Okay. So what do we do about this database? What we're going to do is we're going to split up our data. We're going to make smaller databases. All right. We're going to have like the customer database. And then that's going to have information for customers. And we're going to have like the account database. Okay. And the account database is going to tell us whether or not we talk to the customer database, or whether or not we talk to the driver database, or whether or not we talk to the restaurant database. I misspelled, but you get the idea. Okay. These are going to be different databases. We're going to separate out our data. All right. That's the first thing we're going to do. Separate out the data. So then we're going to make a database for a bunch of things related to the account. And then we're going to make like an orders database. Okay. We're going to have orders, right? We're just going to start splitting up our data, because data is going to be the first thing that's going to balloon too much. And so by splitting these things up, we're going to be able to scale them separately and probably get some cost savings on top of that, right? You have more orders, hopefully, than you do accounts. And so the accounts database doesn't need to be as big as the orders database, right? And so now, instead of having one database that has a bunch of different tables that holds everything, we're going to start splitting these things up into smaller databases. And hopefully this is going to last us for a while, okay? Now, I recognize that you're probably over here going, why do we have a bunch of copies of the same server? Why do we have basically a monolith that's just being run a bunch of times? I'm going to level with you here, okay? Some of the largest internet companies in the world do this. If you've heard of the term monorepo, it's kind of this, okay? Now, whether or not you want to take this approach, or you want to go like with a more hip, cool microservices approach, I don't really care, because by this point, you probably are successful enough that you could hire people to make these decisions on whether or not it's right for your use case. Would I start splitting these things up into microservices? Yeah, probably. I'm probably not going to bank on the fact that I can hire the infrastructure engineers of Meta to be able to keep this replica thing working and having massive and massive and massive bundles for my servers as we start, adding features and adding features and adding features. So sure, we're going to, instead of having a bunch of just generic servers that all do the same thing, we're probably going to have like an account service, and we're probably going to have, like an order service and things like this. So how are we going to make those decisions, right? Previously, we had done a bunch of things around our data, right? We had split up a bunch of stuff. We had a bunch of these different databases, okay? We're probably going to start by just making a service that owns each of these data interactions, and then they're all going to start talking to each other. Now, why are we trying to avoid doing this as long as humanly possible? This is not as simple as it maybe looks to be. All of these network connections, keeping things fast while these network connections are going on, this is hard. This is like a complex things to do. But when you get to the point where you need to start scaling, sure, now we're going to have an order service, we're going to have an account service, we're going to have a driver service, we're going to have a customer service, and pretty much all of these things that were like APIs that we had split up, that were like for customers, that were for orders, that were for accounts, right? Any APIs that we split up along these lines, we're just going to move those APIs into these different services, and then these services are going to talk to one another, okay? This is going to be our basic scaling past the point where we can just have these huge monoliths that we're just going to create replicas of. Now, at the very end, you're going to end up with something for your orders flow that looks something like this. We're going to have a customer client that's going to call out to the order service. The order service is going to call to your auth service to check that authorization header that we talked about, make sure it's valid, make sure that you can actually place this order. Then we're going to send that order over to the restaurant service. The restaurant service is going to be responsible for managing the sockets that go down to the restaurant's client and push that down and say, hey, start making this order. Okay, that's kind of the gist. All right. And we're going to have more microservices. Things will get crazier. But this is kind of like the basic idea of how we're going to start pulling these things out into a microservice architecture. And I kind of feel like I've made my point here. Okay. We're starting by building from the API level of what are the real core use cases that we need. We're going to slap all of those into one big server, all of those APIs, then we can carve out those APIs because we defined good, clean API structure and good, clean data structures. We can pull those out. All the different data structures can go into different databases. And then we can just talk to a bunch of different databases. But then when we get to the point where we need to pull out APIs, we can pull those out into their microservices. And it's all easy. It's easy to scale up because we started by drawing these nice, clean, logical lines. I understand that this is not like a how-to step-by-step. I'm writing no code here. I'm just trying to give you like a general like methodology of how you should start thinking about it when you want to solve problems like this. What are your versions of having the restaurant, the customer, and the driver? Where does your data make sense to drive off, right? To separate off? Where does it make sense for you to start thinking about, oh, do we need a socket here? What does this API's data need to look like? These are the things that I would be doing first when I'm building things. And I would be building them as I do it. I would be building these APIs as I go along and figuring out and making sure that these are ergonomic and that it's nice to work with from the client perspective. I didn't talk anything about how to build a smooth client, but you get the idea. Is that now we're going to have to pay some designer at some point to make it not look ugly. That's not me. I'm not a designer. I'm an engineer. And so this is more back-end focused. But I think the idea kind of holds of we want to start by just getting a working version. And this is how you should get that working version. Now you're going to start getting feedback. You're going to start building new features. And this is where the value is. Finding the fact that, do you have product market fit, right? Is this even a product that anyone wants to use? This is something that like engineers don't start to think about at all. And I get that. But if you're the engineer with an idea, having this mentality of like build first, figure out what people want first, and then worry about whether or not Svelte is 25% faster at this niche edge case than React. Like, you should not be bike shedding on those things. You should be thinking about this. How do you get the simplest MVP in the shortest amount of time? That's why I wanted to show that we can take this monolith and we can scale it. Because I think too many people are worried that they're not ending up with an MVP that looks like this. And I think it's unrealistic and it takes so much time up front to think about these things that you're going to be slow. And it is bad to be slow. You always want to be fast. You always want to be iterating fast. That's the general fundamental methodology around how to build good internet products. I know this has been kind of fast, it's been kind of ranting. I just kind of wanted to throw this out there into the ether, see if it stuck, see if anyone thought this was valuable. If you think this is valuable, I can do this for more types of products, more types of edge cases that people think maybe they, need more information about how we would build. I could expand on this. I could try it for a different company. Like, I don't really care. I think I'm open to try other things here. I just thought that maybe it would be valuable to see how I would go about trying to build like an actual successful product, as opposed to trying to like bike shed on your tech stack for the next 25 years and then never build anything in your life. All right. Hope this was helpful. If it was, feel free to drop a little subscription. I don't know. I haven't been posting a lot recently, but maybe I will. We'll see. All right. Catch you later. Bye.